Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we're going to do the opposite of what we did in a previous lesson. See, previously you were given an equation. You turned it into a table of values or a graph or both. This time we're doing the opposite. You're going to be given a graph or a table of values and you're going to find the equation that represents it. So it's actually pretty easy. The equation of any line can be written as y equals mx plus b. We've been introduced to m before in a previous lesson. M is the gradient, the rise over run. How much y values are changing each time the x value increases by 1. M is just the gradient we've already learned about. B is the y-intercept. I'll show you what that means, but it's just where the graph hits the y-axis. So because any line can be written in this form, all we need to do is find m and find b. So let's look at some examples. We'll start with a table of values. So here we have 3 tables of values. For each of them, we will find the equation that links x and y. Let's start with this one here. So all I need to do to calculate the equation that I require, I need to find m and find b. We know how to find m. We did that in a previous lesson. M is the gradient. It's the number by which y increases each time x goes up by 1. So you can see that y is going up by 1 each time x is going up by 1. So that means that the gradient here is 1. So now what we need to do is find the y-intercept. So what is that? Well, let's say I were to plot this graph. It would be a straight line. So the y-intercept is where it hits this axis here, the y-axis. So along here, the x-coordinate is 0. It would hit the y-axis up at 9. So if it was 9, the line would look like this. The y-intercept of this line is 9. A way you can think about the y-intercept, it's the y value when x equals 0. So that tells us that it will hit the y-axis at 9. That means b, which stands for the y-intercept, is 9. So the equation that links x and y here is just y equals m times x plus b. What does this equation mean? Well, it means if I graph this equation, it will go through all of these points. Another way to think about it, this is the rule linking x and y. This tells you how you get the y value in this table if you know the x value. It's saying to get the y value, you just take the x value and add 9. So minus 2 plus 9 is 7. Minus 1 plus 9 is 8. 0 plus 9 is 9, and so on. It's a rule telling you how to get the y value if you know the x value. So let's look at this table over here. Calculate the gradient and the y-intercept. So for the gradient, we know each time x is going up by 1, y is actually going down by 2. So the gradient is negative 2. What is the y-intercept? It's the y value when x equals 0. So it's minus 11. So the equation of this line is just y equals mx plus b, minus 2x minus 11. Once again, this is a rule that tells us how to get the y value if we know the x value. It says times the x value by minus 2, then subtract 11, and you get the y value. So minus 2 times minus 2 is 4, minus 11 is minus 7. This point here works too. If you go minus 2 times 2, then subtract 11, you get this value here. All right, let's look at this one here. So this is a bit tricky because once again, x is not going up by 1 each time. It's actually going up by 2. But we learned how to deal with this situation in the lesson on the gradient. So each time x goes up by 2, y goes down by 6. So the gradient here is minus 6 over 2, which is minus 3. This is saying each time x goes up by 1, y would go down by 3. And that makes sense. If I put x is minus 2 in here, the y value would be 6. If I put x is 0 in here, the y value would be 0. And so on. If I put 2 in here, I would get the y value minus 6. So that's what happened if I did the table completely. Each time x goes up by 1, y goes down by 3. So if x goes up by 2, y goes down by 6. So gradient's minus 3. So the y-intercept, well, it wasn't listed on the table here, so what I had to do was add it in. So if I know that each time x goes up by 1, y goes down by 3, I knew that this number would be 0 because x went up by 1, y went down by 3. The y-intercept is 0. I can just add it into the table if it's not there. So that means the equation of this line will just be y equals minus 3x plus 0. I don't need to write the plus 0 though. So this is saying that each y value is just negative 3 times the x value. Minus 3 times negative 3 gives 9. 3 times negative 3 gives minus 9. 5 times negative 3 gives minus 15, and so on. All right, let's look at finding the equation of a line now when we're given the graph. So let's say I'm given this graph here and I want to find its equation. All I need to do is find m, find b. So m is the gradient. Remember, it's the rise over the run. So I've gone across 3 and up 6. The gradient is going to be rise, how much I've gone up, divided by run, how far I've gone across. The gradient is 2. The y-intercept, as I said, is just where it hits the y-axis. It hits at 6. So the y-intercept's 6. The equation of this line is y equals mx plus b, y equals 2x plus 6. So let's say we're given this line here and we want to find its equation. Same thing, we need to calculate the gradient and calculate the y-intercept. But I'm going to show you a different way. See, some people like the tables. What we can do is we can take all the points that are plotted here and put them into a table. So the table would look like this. I got this table just from putting in the x values and the y values. So like minus 1, 8 is this point here, 0, 5 is this point here. So once we put it in a table, we can do exactly like we did on the previous slide. So here, each time x is going up by 1, y is going down by 3. So in this case, the gradient is minus 3. The y-intercept is the y value when x is 0. It's where the line hits the y-axis. It's 5. So the equation of this line is y equals mx plus b, minus 3x plus 5. So when you're given the graph, you can do either way. You can put the points in a table like I did here, or you can just calculate the gradient using rise and run and look at the y-intercept. Either way is fine. All right, let's look at some more complicated examples. So let's have a go at these questions here. So firstly, find the equation of a line with gradient 3 that passes through minus 2, minus 5. So we know that the equation of this line is going to be y equals mx plus b. Because we're told the gradient is 3, we can just replace this with 3. So we're following the same steps as the previous slide. We're finding the gradient, although here it was told to us, and now we're going to find the y-intercept, which is b. So how are we going to find that? Well, what I can do is take this equation, substitute the x value and the y value, and solve for b. So what I'm going to do is I'm going to change y to be minus 5, and I'm going to change x to be minus 2. And then I have an equation with one unknown, which is b, and I can solve it simply. Minus 5 equals minus 6 plus b. Add 1 to both sides, you get b is 1. So in this example, the gradient's 3, the y-intercept's 1. So the equation is just y equals gradient times x plus y-intercept. So for this equation here, I'm not told the gradient, instead I'm given 2 points. But we can still follow the same process as the last time. The only difference is we're going to need to do a little more work to find the gradient. So what I'm going to do is I'm going to plot these 2 points. So minus 1, 5 will be the point up here, and the next point, 2, 1, will be like over here. So what I'm doing is I'm finding the equation of the line that goes through these 2 points. So plotting it's going to help me find the gradient. So remember, I always start at the leftmost point, I go to the right. So I start here, and I'm going to end up at this point here. So to do that, I'm going to go down 4, and I'm going to go 3 to the right across 3. So the gradient is rise over run. So now this question is the same as the one I just did. Now I know the gradient. What I'm going to do is I'm going to take my equation y equals mx plus b. I'm going to substitute the gradient for minus 4 over 3 because I just figured that out. And now I want to substitute value for x and y. So here I have two choices. I have 2 points. It doesn't matter whether I choose this point or this point. I'm just going to choose this one because there's no negatives. It's easier. So I'm going to change y to 1 because the y coordinate at that point was 1. And I'm going to change x to 2. So now I have an equation to solve. So minus 4 over 3 times 2 is minus 8 over 3. I'm just going to add 8 over 3 to both sides. I get 11 over 3. That's B, the y-intercept. So the equation of this line is y equals gradient times x plus y-intercept. All right, let's look at this last one, which is a worded problem. Plumber charges call-out fee plus an hourly charge. They charge $210 if they work for 2 hours, $450 if they work for 5 hours. We're going to find the equation that links the amount charged with the number of hours worked. So what I'm going to do is I'm going to let the amount charged be y and the number of hours worked be x. All I'm doing here is finding the equation of the line that passes through 210. So when x is 2, y is 210. When x is 5, then y is 450. So all I need to do is find the gradient and the y-intercept. So here, what's happened is x has increased by 3, y has increased by 240. So the gradient here is the change in y, how much I've gone up. The y values have increased by 240, the x values have increased by 3, so that's 80. So the gradient of $80 means the plumber charges $80 per hour. Now I need to find the call-out fee, the y-intercept. So I take my equation y equals mx plus b. So I'm going to substitute m for 80, which I just figured out, and I'm going to substitute x and y from one of the points. So remember, it doesn't matter which point you use. I'm just going to pick this one here. It wouldn't matter if I pick the other one. So y becomes 450, x becomes 5. I get 450 equals 80 times 5 is 400 plus b. And of course, that means b equals 50. So this plumber charges $80 per hour plus a $50 call-out fee. So the equation is the amount charged is equal to $80 per hour plus $50. All right, thanks so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.